This meeting is being recorded.
This video from chapter 20 is going to be a continuation of problem 20.30. So in the previous video, we saw parts A through D. Now in this video, we're going to cover parts E through J, so the remaining portions. So let's take a look at example E here, and we begin with a carboxylic acid, and we need to convert this to a nitrile, or that's our finished product. So we can do this in a few steps here. So in this first step, we can convert our carboxylic acid, shown above here, to an acid chloride using thionochloride. Then we can treat our acid chloride here with excess ammonia, and this would give us this amide intermediate shown here. Then in our last step, we can reduce this using lithium aluminum hydride and water in a workup step here. So we get our finished product here. Or we can also utilize thionochloride again, which is given in the answer key, to this nitrile here. So either of these reagents would accomplish this same result. Then we have in part F, I noted here, this can happen in a single step. So this transformation involves the hydrolysis of this acetic anhydride. And we can accomplish hydrolysis using simply water to generate this carboxylic acid product shown here. All right, let's take a look at G and H now. So G, notice we can accomplish this also in a single step. We can treat our acid chloride here with ethanol to create this ester here. We need to install that ethyl substituent, that ethyl portion. We're actually going to install all of this, and then we need to use pyridine as well to absorb that hydrogen, so we don't produce those acidic conditions. So this is our ester product, and again, we would just use ethanol, so ETOH, and then pyridine here as well. This is commonly abbreviated just PY, so you may see that. In part H, so we can perform hydrolysis of an amine, or our amide rather here, with aqueous acid, so H3O+. We can again convert this to carboxylic acid here initially, and then upon treating this with thionochloride, we can produce this acid chloride intermediate here. And then in this last step, instead of using lithium aluminum hydride as a reducing agent, we can use a sterically hindered, this would be lithium, aluminum, and then we have these 3 alkoxy groups instead of hydride, 4 hydrogens. So this is a tri-alkoxy aluminum hydride reagent, and again, it's sterically hindered. So when we use this in combination with an aqueous acid workup, we could generate this desired aldehyde product. So our last two reactions here, reaction I, this will accomplish through, first we can perform hydrolysis of our nitrile here, and we could do that utilizing H3O+ and heat. So acidic conditions and high temperatures, we get this carboxylic acid intermediate shown here. And then if we treat it with excess lithium aluminum hydride, and then our acidic workup conditions, we can generate this primary alcohol product. All right, in our last reaction here, we see that we go from a primary alcohol to this nitrile product here. So we can accomplish this in 4 steps. So step 1, we can take this primary alcohol and then using those, the sodium dichromate, with sulfuric acid and water, these three reagents, we can oxidize this to our carboxylic acid shown here. Now take that carboxylic acid, treat it with thionyl chloride, we get our acid chloride intermediate shown here, our second intermediate. Then to produce this amide, we can treat this with excess ammonia, get our last intermediate, this amide intermediate, and then we can dehydrate this using thionyl chloride and produce our nitrile product.